Hi, welcome to a very brief introduction to this paper published in Climate. I'm Dr. Alec Feinberg from DFR Soft Research from Northeastern University. Let's look at the simple concepts first for time left in the paper. Global warming is treated as due to forcing, which is what we do, and feedback, such as snow and ice melting, which causes more warming because we're losing reflectivity. And we estimate in the paper that when feedback gets too high, about 71% of the global warming problem, mitigation will be very difficult to make progress. And this is called mitigation critical, uh, estimated to occur in about 50 to 100 years. In response to that, we talk about annual solar geoengineering because CO2 goals have shown poor progress. And solar geoengineering is about 14 times more efficient than CO2 reduction. It's optimum to use what we call an annual approach to stabilize yearly global warming increases. The plus refers to a little bit more than annual stabilizing annual increases. So let's look at a little more detail in the time left. What we want to do in the method is to estimate the percent of global warming occurring over time due to feedback. So we model that and we identify the 71% point. And it's also shown in the paper that if you multiply 0.71 times 0.71, we get the feedback loop portion, and that's rigorously shown. Now, the feedback loop portion is important because that's a chain reaction portion of global warming. We're more concerned about things of that nature. So example is that if we get to the point where we get 3-degree rise, if this was the correct number around this time period, we get about 1-degree rise for forcing and about 2 degrees rise for feedback in that case. So this is the results of the modeling that we find for feedback over time for the fractional percent global warming increase due to feedback, and also the feedback loops. And you can see the 71% area corresponding to 50% feedback loops. And because feedback amplification amplifies the forcing, we use that quite a bit in the paper. We use this equation to convert to percent global warming. For example, if feedback, which is about what it is today, about a factor of 2, feedback amplification, that gives you in this equation about 50% of global warming is due to feedback. And if you want to convert that to IPCC type units, you just divide the amplification factor divided by the Planck parameter. Okay, so we get these, it's shown in the paper some substantiated or higher confidence points in the graph. Now, how do we get these feedback amplification trends? What was done was we looked at slopes. So the slope of the energy consumption, which was shown to be directly related to forcing, looks a lot lower than the slope of global warming. So why is it a lower slope when we normalize it? We can compare them because of amplification. So the ratio of the slopes gives us that. And notice it also takes out some of the time lag. A lot of the time lag when you look at slope, as the slope trends are very steady. It also, we don't have to worry about aerosol forcing, which has been fairly constant, not an increasing trend like the other effects here. Okay, so we get these figures which help us to determine when we're going to reach that 71% point for mitigation critical, and that comes out in about 75 years. And at that point, we'll roughly double. If we go 1 over 75, it tells us the increase on a linear scale of what the percent mitigation difficulty will increase every year until about 202100. It will roughly double what it is today. So in response to that, we recommend annual solar geoengineering plus pathways because the annual approach is the most feasible option, political governance friendly, 50 times less area effort. It leads to a smaller area by a factor of 50. And we want to make sure that we use all possible methods, which includes urbanization, earth brightening, hotspot earth brightening, and these areas are very easy to deploy compared to space sun shading and tropic and Antarctic areas that we want to target with stratosphere aerosol injection. which are much harder to deploy weight by weight. So we want to make sure that we have good habits and not darkening the planet with these roads. So I provide you with the provided is the area requirements and the physics for the annual pathways. We provide also the amplification estimates, and we show that the Arctic and the tropics have a higher amplification, so they have more of a tendency for self-cooling, promoting that. So some of the key takeaways are that solar geoengineering is required to meet our CO2 goals and help in that area. Full solar geoengineering is too difficult. The annual approach is faster, uh, and in about 50 to 100 years, the time left will be critical if we don't mitigate now. The largest emission countries are showing poor priorities for CO2 mitigation. Political friendly for annual solar geoengineering. The PLUS pathways can promote a measure of self-cooling, and deployment by weight is very challenging for space sun shading and stratosphere air soil injection. Thank you for listening, and I hope you get a chance to read the paper.